Hello and welcome to Martin Maths. I'm doing a video for my year 9s on plotting, distance formula, gradients and midpoints. What we're going to look at is using a visual rather than just the formula, because I think always visualizing it really helps. So imagine we have the point 1, 2. Now remember, we always plot x and then y. So across and then up. So 1, 2. So that's the point A. Then say there's another point 4, 6, and we'll call that B. So we go across to 4 and then up to 6. Now this is just a sketch, so the scales might not be the same. But then there are a number of things we might want to know about this. We might want to know what the distance between A and B is. We call it AB, like that. Now there is the distance formula, but that is just a rearrangement of Pythagoras, because that is one side squared and that's the other side squared. If you squared both sides, D would be the hypotenuse of this right angle here. So that side, which is y2 minus y1, 6 minus 2 is 4, and this side here, which is x2 minus x1, is 4 minus 1, which is 3. Fortunately, in this example, it's a Pythagorean triple. 3 squared plus 4 squared is 9 plus 16, which is 25. And the square root of that would be 5. So just a nice visual there of the right angle. So yes, I could have plugged that all into the formula there. 4 minus 1 squared, 6 minus 2 squared, and then square rooted would have given us that. Okay, then we want to know what is the midpoint between A and B. So if I look, the midpoint is going to be the middle of the x value and the middle of the y value. What's between 4 and 1? Well, it's there. But the formula says add that and average it. So 4 plus 1, and take the average of that. And this one is 6 and 2, and average that. So we get 2.5 and we get 4, which is just what we'd see if we were to look at it as well. Okay, so that's the midpoint formula there. You're averaging those two x values, averaging those two y values. Next idea we might want to know is what's the gradient of that, so what's the slope of that? And again, we're going to use things we've calculated already. It's going to be the change in y over the change in x. If we look at this formula sheet here, that's delta y over delta x. That's the some people like to call the rise over the run. So we had 6 minus 2, which is 4, over 4 minus 1, which is 3. So its gradient is 1 1/3, going up by 1 1/3. It was, as I said, 4 over 3. Now, for my students, as we continue that, we will know then that all lines that are parallel to this, that's a symbol for parallel, will also have a gradient of 4/3, and all lines that are perpendicular to that will have the negative reciprocal, so minus 3/4. So there we go. That was a quick example of using a distance formula, using the midpoint formula, using the gradient formula, parallel lines, and perpendicular lines. But as I say, I do like to visualize it. It might got a bit complicated there because I had a lot going on. Distance, midpoint, and the gradient. Thanks for watching. Don't forget to like, subscribe, and share.